Let's discuss some additional IPv4 address types. We've talked about a few so far, and I've mentioned the host IP, we've mentioned a network address of some kind. So let's list off a couple different address types in IPv4. The first kind that we're going to talk about is the network address. You know what, we'll list all of them off. We also have host address, and we have a broadcast address. Every network has these types of addresses in IPv4. Now remember, on my example, in my network here, I have an IP of 192.168.77. I think it was like 151. So that's assigned to my device. That's my end node. That is my host address. The host addresses have to be in the usable range of addresses is the best way to describe it. The network address is your first IP address, and the broadcast address is your last IP. So let's put that down, and I'll show you how that makes more sense. First and last addresses, and then the host addresses they are all everything else, everything in between the first and last addresses. So in my example here, I have a subnet of /24. So that's 255.255.255.0. Remember, I was talking about the dividing line between the network address and the host address, and you have that /24, so that means those first 3 octets are for the network. So the first address in this example would be 192.168.77.0. The very last one in this, the first address, that means all the bits on the last octet are set to 0. So that's how we get that. The very last, it's all set to 2. All of them are set to 1, so it's going to be 255, just like the subnet mask. So if we turn on all 8 bits on that last octet, it's going to be 255. So let's write that down, 192.168.77.255. That's going to be my last address. Everything in between there, from .1 down to .254 in this subnet, are going to be available host addresses. So the very first IP that you can create in a subnet, even though it may end in 0, is your first address, and that is your network address. That's the number, the name of your network. So if I am referring to a subnet or something, I might say this is the 192.168.77.x or .0 address that for the subnet. The broadcast is going to be the very last. Sometimes they don't end always at these very nice perfect 0 and 255 range. Once we get into subnetting, you may have a network address that starts with 12 and it might end with something completely different. It might you may have a larger than /24 network where it might be a /23 or 22 or something like that, and .0 may actually be a usable host address in the middle there. So don't always consider 0 as always the network and 255 as always the broadcast. It depends on the subnet that you're in. Depends on the size of it. But in a very basic home network where you're using a /24, pretty standard type network size, this is very common, the .0 is going to be your first address. That's your network address, and the very last is your broadcast address. The network address is the name of your network, as I said, is the first number that defines your network. The broadcast is the very last. And the broadcast is very special. The broadcast actually, if you send traffic to the broadcast address, it will then send it out to every single, it'll send it out into the network, and every single host will listen to that broadcast and then do something with it. So people refer to it as being sent out to everyone, but really it gets sent out onto the network with a destination address of 192.168.77.255. And every single other computer on this network regardless of what IP address is configured on it for its host address, it will still listen to and interpret whatever traffic gets sent to 255. So it broadcasts to it. It is a way of sending traffic to everyone on the network. That is used for certain protocols as well, such as DHCP that we've mentioned. DHCP, when a computer comes online, it's going to send out a broadcast saying DHCP discover, hey, who's out there, who's my DHCP server. That's going to be a broadcast. And there's others out there that are like that. That's a very common thing to see using the broadcast address, and that's why subnets come in to play, and that's why they become important, because we want to limit the amount of broadcast traffic that we have on our network. If you have a very large network of many thousands of devices on one subnet, if you have a few hundred of them sending out broadcast traffic all the time, it's going to reduce your bandwidth on your network and bog down your end devices, because you're having to interpret all this broadcast traffic. So going back to our networks and subnets, as I mentioned, this is a common subnet you'll see, and we'll talk about this going forward, but it's really, people sometimes refer to it as a Class C address. It's a /24, and the 24 comes from the 8/16/24 bits in the network side, and we refer to that as the prefix length. So I keep saying /24 as another way of saying this, and that's what we refer to as a prefix length. When we get into IPv6, the phrase prefix length will become much more common. Right now, people usually refer to it, oh, it's a /24 network, the decimal notation is this. But when you start talking IPv6, everything is in prefixes. So get used to using the prefix notation, especially when you're discussing subnets with other network engineers. We usually say, oh, it's a /something. And so start using that, especially going forward with IPv6, since it's so common with that. We've gone over some of how to calculate addresses, so I won't reiterate that, but some of the packet types we have. So I mentioned broadcast address. So obviously we have broadcast packets that use this broadcast address. So let's talk about some packet types in IPv4. So we have some Unicast. We have multicast, and then we have broadcast. Unicast goes from one device to one device. So if I'm sending you a packet, I'm coming from 77.151 and I'm going to 77.1. That's a unicast packet. It goes directly to you. It goes out on the wire, and anyone else who's on that wire is not going to interpret that packet. They're going to ignore it. Anything that is a multicast address, that goes from one to many. The way a multicast address works is the network card may, on a system, may be listening to not just for its own host address that's configured in it, but depending on what services may be running, it may be listening to specific multicast addresses. And I'll write down the different types of address ranges as well, but there's a specific range for multicast addresses in IPv4, which is the 224 range and up. And I'll write that down in a minute. But the multicast address is used for specific things such as dynamic routing protocols, or if you are like ghosting doing a ghost of an image on a lab or something like that in a school or something, or some sort of computer lab, you're trying to ghost it all and overwrite the OS, you might use a multicast address. Video conferencing might use a multicast address, things like that. So the way the multicast works is it'll go out onto the wire from whoever's generating that traffic, and then it'll be received by everyone, but then only those computers or those end nodes or whatever it might be that are configured to listen for that multicast address, that specific multicast address, they're going to interpret and process that and send it up the stack. So the Unicast is, if I'm configured as 77.151, then anyone who sends traffic to that, well, that's me, so I'm going to process that. If I'm also running OSPF, if I'm running a routing protocol that we'll talk about later, I might be listening on a specific multicast address for that, or egrep or something like that. And then if someone sends traffic to that address, well, then I'll process that as well because I'm running that service. I need to process that traffic. And then additionally, we have broadcast, which gets sent from one to all. So the broadcast address is an address, as we mentioned up here. It gets sent to everybody, and then everybody processes that traffic. So you might be looking for a MAC address or something. You might be looking for you might be looking for anything, a DHCP server or something like that. And we can have broadcasts. We can have these types of addresses as well at other layers. Like when we start talking about layer 2, we'll have similar subset here of different types of addresses. So we have that in layer 3 with IP as well as below with layer 2 and such. We'll talk about that. So let's talk about some of the IP ranges that reflect these types: unicast, multicast, and broadcast. So let's clear this out. And so for the host addresses, which really is let's not call it, what's hosts / usable by whoever. Anything from starting from 0000 up to 223. Whoops. Anything from the very first IP that's available to up to almost 224, those can be used for networks. So that's like network usable address range. So anything that goes from 0001 up to 223, 255, 255, 255 are valid addresses that you can use for a network. So it might be what we call public network out on the internet. Like if you go to Google at 72 dot something or whatever, he's going to be in that range. If you have a local network, 192.168, that's going to be in this range. If you have some other private network like 10 dot something, which we'll go over, that's also in this range. If you access anything on the internet or local network with unicast traffic, you're going to be hitting something in this range. If you want to speak over multicast, that actually has a specific range of IP addresses in IPv4, and those start at 224, and they go up to 239. So anything in that range are those types of services, as I mentioned, dynamic routing protocols, ghosting something or doing some sort of golden image to a bunch of systems for lab use, something like that. We'll be using multicast voice of, maybe voice conferencing or video conferencing might use a multicast address. Those are specifically reserved for multicast use. There's also one such as experimental, and then I'll also put this down private since I mentioned it. So the experimental, those were blocked off at the beginning of IP, and you can take a look at some of the RFCs. I'll write them down in a second. Those were blocked off for future use. Unfortunately, that future use really never came, and we've switched over to IPv6. So these are basically unused addresses that were supposed to be used at some point, but really weren't. So anything from 240 and up really is for that experimental block of addresses that were supposed to be used in the future. So those are essentially unused. Most everything you'll find is going to be in that 0 to 239 range. It's going to be either hosts, like network addresses, hosts, some broadcast addresses for the subnets are going to be in here. multicast traffic is going to be here, and then above that that's pretty much it. But within this network host usable range, there's some private ranges. They're very specific, and these came about because of the exhaustion of IPv4 many years ago. They said, hey, let's come up with a way of having addresses only in an internal network, which nowadays sounds kind of crazy because that's what we all do. Why wouldn't we do it that way? But the original design was that everyone in the internet had a specific address, and it was, unique to you. So if I had 192.168.77.151, well, I'm the only one that has that. Everyone had what's essentially we call nowadays public addresses. Everyone had an IP address that was unique to them on the internet, which was, as it increased in popularity, became very wasteful, because you might have a business or something like that with 300 computers. Well, then they're going to be using 300 IPs on the internet. Is very wasteful. And some of the very large organizations, if you go and look at the IANA addressing list of who has what blocks of addresses, some very famous old companies have very large swaths of public addresses for IPv4 because that's what they were given back then. There were no private addresses only for internal networks. Everything was public essentially. So we'll get more into what that all means, private and public and stuff like that. But that what came about with network address translation with NAT, and that really helped with the private address idea, where you could then translate an internal private address to an external public address, so you could hide 300 computers behind one actual IP. And so we'll get into that later on. But the private ranges that we use on almost every internal LAN is they start at this 10.0.0.0, and that's a /8. We have 192.168.0.0/16, and then we have this slightly weird one that most people don't use, and that's a 12. So, and you know what, I'll write down these RFCs while we're here. So this was RFC 790, 1700. This was 1700 as well, and was at 33.0, and then this was 1918, which is this one's really famous. If you go read anything, go look at RFC 1918. So this is the definition of the IP addresses that are not routable on the internet. So everything else in the 0 to the 223 range, it could be potentially routed on the internet, except for these ranges. These ranges are now defined as internal private addresses, only for use in your internal private network. So if I have a 192.168 something IP address, if it ever gets somehow leaked by my router out to my ISP, they're going to drop it. It's not supposed to be routed. No one can get to it. If someone gives you their IP address and it's 10.something, well, then it doesn't matter, that you can't get there. It's a private address. It's only valid on your internal local area network. And when it comes to these slashes, remember we're talking about prefix length. So we have /8, 16, and a 12. So what does that mean? That means /8, that's going to be your first octet. So anything 10.anything is private. That is a lot of IP addresses that are available. I mean, you can do anything with that. It's huge. 192.168, that's /16. We're going to stop here at the second octet. Anything 192.168 dot whatever, those are all private. And then this one, 172.16, that's part way. That goes up to .31. So that goes from 172.16 to up to 172.31. That's also a relatively large range to work with as well. Most people choose the top two though, just because they're a little easier to remember. But remember I was mentioning my local network is a /24. Technically, it's a subnet of this range. This is considered, if you want to go back in the old days, they would classify IP addresses based on class A, B, C, D, and this is technically a class B address, and when you make it into a /24, you're subnetting that, and we'll talk about that in the next video or so. But those are the ranges that you use for private addresses with IPv4. And there are somewhat equivalent things with IPv6, and we'll talk about that as well. IPv6 kind of goes back to that original, due to the huge number of IPs that are available, they kind of gone back to the whole idea of everyone being a unique address on the internet. Everyone's a public address kind of, and but they do have a private method of doing that. We'll talk about that in the future. So those are the RFCs to take a look at. Some special addresses. Let's talk about some special addresses. So we've talked about some of these. Some other ones we want to take a look at. I've mentioned them already. Let's blank this actually. So the one that we've mentioned is quad zeros. That's your default route. When you're looking at a route table, if it doesn't match anything else in the route table, it's going to match this. And then this is going to send it out to some sort of router. That's your catch-all for all your traffic. And when we go over the ANDing process, that'll make sense why all the zeros matches everything. Another one, which is constantly referred to, is 127.0.0.1. That's your loopback. The loopback is a special address in IPv4 that lets you ping yourself. So it's often, well, it allows you to access yourself, but it's commonly used for diagnostics. You can ping with which ping is an ICMP packet used to usually do network diagnostics to see if something's available, if it's up or down. You can send traffic to that address, and it will send it through your TCP IP stack. It'll go through the layers. So you can actually, if you're on your own system, I can ping myself. So that pings myself. And it goes through the network stack, it goes up and down through the layers, and makes sure everything's working correctly. It's a great way of testing to make sure your local network card, your drivers, your operating system is all working correctly. You also have an interesting range, which you will see on occasion if things aren't quite working right on your network usually. 169.254.0.0, and that goes up to 169.254, whoops, .255. And that is your link local. Also known as a PIPA, as I like to call it, which a PIPA stands for the Automatic Private IP Addressing, and there's an RFC for that out there as well. But the idea behind the PIPA or link local address is if you turn on a computer, and you might have seen this before, if you turn on a computer and nothing's plugged into it or something like that, or if it has a network connection but it's not quite working correctly. The idea is if something comes online and it's set to retrieve an address, an IP address through DHCP or bootp, and it doesn't get one. If it doesn't get an address from that DHCP server, then it will essentially negotiate one of these an IP address in this range with all the other devices on the local network and assign it itself. So it'll kind of make up its own IP address somewhere in this range, and it'll check with the other devices to make sure no one else is using it. It's a great way of knowing if almost all networks have DHCP running. So if you plug in a system and it doesn't get a DHCP response, especially if it's on a workstation subnet or something like that, they all have that. If you're not getting that and you end up getting a 169.254 address, well, then you have something else going on that's not right. Something with the network card, the drivers, the operating system, the cable itself. You're plugged into the wrong port, something like that. It's a great way of knowing that something is going wrong and you're not where you're supposed to be. And then there's another one that's used for testing purposes. and actually it's one I should probably be using a bit more, but whoops. 192.020, and that goes up to 192.0.2.255. So it's just a /24, and that's used for testing or teaching purposes. So that's the basic idea behind all the different types of addresses. We'll get into classful and classless and subnetting and such going forward, but those are some of the basic IP addresses you'll see. Make sure you know about the link local and the APIPA addresses and the loopback especially. The quad 0 default route, that's very important going forward. The testing one, not so much. But from here we'll go on to address assignment and talk a little bit more about network sizing and subnetting, and we'll move on from there and start creating some smaller networks.